Chapter 3, notes, continued. Today we're going to look at the distributive property, and we're going to look at it in three different ways. The first way is just the basics. You've probably seen this before, but this first example, we have 3 times x plus 7. So that 3 has to be multiplied by both numbers in parentheses. So it has to be multiplied by the x and the 7. So we do 3 times x, which is 3x, and then 3 times 7, which is 21. The little rainbows on top are not required, but I think they're a nice visual aid to show you exactly what you're doing. That's called distribution, and you can think of it as you're distributing the 3 to everything that's inside the parentheses. The next example on the right, same idea. I like to draw those. Some people draw them underneath. You can make them square, whatever you want. Something to tip you off that remind you that that negative 5 gets multiplied by the 2x and the negative 8. So negative 5 times 2x would be negative 10x. And negative 5 times negative 8. And if you're a little confused about that's negative 8, remember you can always do plus the opposite. So just emphasizes that it's negative 5 times negative 8, which is positive 40. Okay. You can do distribution using a generic rectangle if you want. I've set one up here for the next example. The 7x would go on the side with just one length, and the x minus 10 would go on the other side. And then we just do the multiplication for each box. So 7x times x would be 7x squared, and 7x times negative 10 would be negative 70x. And then, of course, we usually write the final answer, 7x squared minus 70x. And like before, we always write the x squared term first, and the term with just x comes second. So that's just normal distribution, very simple. Our next section here is called combining like terms, and one of these, the second example of this, will have a distribution component of it. By looking at the first example, when we're combining like terms, I'm sure you've done this before, but we're only allowed to combine terms that have the same letter. And then they have to have exactly the same letter. So like 8x and 6x, I can combine those, and that would be 14x. The negative 5y can combine with the positive 4y, which would be negative 1y, and we would just write negative y for that. And if there isn't a letter at all, those numbers are considered like terms too, and those are called constants. So 7 and negative 2 would be positive 5. And there's nothing else I can combine because I can't combine x's with y's, and this term doesn't even have a letter, so that would be my final answer right there. On the example to the right, you'll notice I have 8x minus 5y plus 7, and then I have subtract, and then in parentheses 6x plus 4y minus 2. Now, when we have a negative sign that's outside parentheses like this, that is a distribution situation, because I'm subtracting everything that's in the parentheses. So my suggestion is to rewrite the problem. So 8x minus 5y plus 7. And then I'm going to distribute that negative sign, which is really like distributing negative 1. So it'd be negative 1 times 6x, which would be negative 6x. It'd be negative 1 times 4y, which would be negative 4y. And negative 1 times negative 2, which would be positive 2. Remember, a negative times a negative is a positive. Now I have some like terms that I can combine. I have an 8x and a negative 6x. That would be 2x. And some people like to circle these to make it more obvious. And then I have a negative 5y, which I'll combine with negative 4y. Those are like terms. and that would be negative 9y. And then of course I have the constant plus 7 and the constant plus 2. If I add those, I get 9. Again, there's nothing else to combine there because I can't combine x's with y's, and the 9 doesn't have a letter. So just remember, if there's a negative sign followed by parentheses like this, that negative sign gets distributed to every term in parentheses. Okay, and you can pretend there's a 1 there, so you're multiplying negative 1 times all of those terms. Now, our third thing we're going to discuss today surrounding distribution is solving equations. And this is pretty straightforward. First, we're going to distribute. So I'm going to distribute that 3 to both terms. So it'll be 3x, and then 3 times negative 2 is negative 6. And now I have a two-step equation that I can solve. And my first step, of course, would be to add 6 to both sides. This is a good review of solving equations. So I get 3x is 27, and then I would divide both sides by positive 3, and I would get 9. And remember, when we're solving equations, it's always a good idea to take your solution, plug it back into the original equation, and you can do this in your head if you wish. It would be 9 minus 2 is 7, and 7 times 3 is 21. So I know I'm correct. For example 2, I'm distributing negative 4 to both things in parentheses. So it'd be negative 4 times 2x is negative 8x. And negative 4 times 1 is negative 4. And now I would go through my solving steps. So first I would add 4 to both sides. I'd get negative 8x equals 17. And then I would divide both sides by negative 8. And I get x is negative 17/8. And it's okay to get a fraction. There's nothing wrong with that. That is how we use distribution to solve equations.